do what I want you to. Okay. Oh. Yeah, blood red. All right. So we last time we talked about how to put something that looks like this into this poor thing has been written on so much. Let me try to get a nice one. There we go. Something in this form, which they call standard forms for them. I'm going to call this standard form because it just is. Into this form here. Why is this form preferable? Somebody tell me, looking at this, how would you know if it opens up or down? What would you need to know? If A itself is negative or positive, so if A is positive, it opens up. A negative, it opens down. That just makes way too much sense, Jeff. Math is normally more evil than that. True. A positive up, a negative down. Can somebody tell me what the vertex is of this? Yeah, it would be H, K. I love it. So see, it's the opposite sign of the thing inside, and then the same sign is there. That's related to how it transforms, how it moves. So the vertex starts at 0, 0. Minus H, so I've got to make the x go the opposite of that. It's got to overcome that, and then it's got to go up and down whatever k is. So we did a couple examples of graphing those earlier. Let's do one more right now while we're thinking about what that means, what I just said. Let me find some paper. Let's see, who is no longer in this class? Steal your paper. I don't know if you're ever going to show up again. Let's see, blah, blah, blah. My kingdom for paper. Here we go. I can steal somebody's number of paper. Ooh, look at all that paper I got. Yeah. It's all lined and shit. Right? So let's try something out here before we get back into writing in this form. Yeah, I like it. Okay. So how does this open? Does it open up or down? Down. Good. That's negative. It opens down. Where's the vertex? Negative 2. 6. Again, this is a remarkably simple idea, but it's a little, mixed up in a lot of other stuff. But if I'm adding 2 to my inputs, all my inputs can be 2 smaller than they used to be. Therefore, everything moves back 2. So the vertex normally is at 0, 0. Now, since all my inputs can be 2 less than they were before, it goes back 2. Another way to look at it is, what makes it 0? Negative 2. Right? Well, it used to make it 0, 0, but now negative 2. So now it moves back there. And then this takes it up 6. Just moves the whole thing up 6. Whatever those outputs were, and now all the outputs are 6 bigger than they used to be. So let that make you sneeze. Let that make remarkable amounts of sense. Please. How about the y-intercept? How do I find the y-intercept? Yeah, make x 0. So negative 4, bless you. Negative 4 plus 6. So what's the y-intercept? 0, 2. I like it. And what about the x-intercepts? How do you find the x-intercepts? Yeah. Make y 0. F of x is just a replacement for y. So here, you guys do this. Find the x-intercepts. We'll see if it'll actually hit the x-axis or not. If there's real x-intercepts, it hits the x-axis. If there are no real intercepts, it don't. Oh, shice, I got nothing. See how long it can last. Crap. Somebody else's Twitter, I don't trust that. So how are you guys solving this? What are you guys doing? Track 6, sure. Divide by -1. Sean. Get his attention. Are you doing this? Yes. There you go. Get all serious. -1. So you get 6 equals x plus 2 squared. And then, of course, you square root. The minute you do that, you should... No. So you're going to do next. The minute you put a square root, plus or minus. They kill each other, so I get x plus 2 equals plus or minus square root of 6. So I get x equals -2 plus or minus square root of 6. Because one step further, you guys got a calculator? Anybody willing to help me out? So what is -2 minus square root of 6 and -2 plus square root of 6? What are those? Give me some decimal approximations. Do it again, sir. -4.495. This will be, let's see, so this will be .495? This is 949, and so this is probably -4.44. Do you have enough 4s in there?
Yeah. So you have 1 more.
All right. Woo! That was exciting. So basically, -4.5 and a half, almost, right? Almost. All right. So you guys, this is the exact answers. These are much more useful for trying to plot, estimate where they are, or what's that graph that I can make sure doesn't make sense. If you look at a graph and I say, where's -2 plus rad 6, you're like, you got me. So you might as well make a decimal approximation so you can kind of see where it is. Mark.
Test, which answer would you like?
I'll be very specific as to which way I want it. I'll say, give me an approximation, or I'll say, give me the exact answers. If I don't say, then either one. Okay. So look at all this information. Let me recollect all the information over here we just figured out. Opens down. The vertex is at -2, 6. The y-intercept is at 0, 2. The x-intercepts are -4.4 roughly and 0.45. There, sure, okay. So let's see what happens. Let's try to graph this thing. So most important points. Where's the vertex? -2, 6. Okay, that's so exciting. Where's the y-intercept? 0, 2. Where's the mirror? Where's the axis of symmetry? The axis of symmetry is a line. It's not a point. X equals -2. So where's there got to be another point then? 1, 2. 1, 2. It's got to be a mirror image point over there. Because that axis of symmetry is a mirror. Every parabola is perfectly symmetric. And if we just want to kind of estimate the x-intercept, I could kind of graph it right now, but let's see. The x-intercept is supposed to be at like 0.45 and negative 4.4, so like roughly there. And that's about where it looks like it wants to go. Weehaw! Okay. That's basically just everything done all in one problem for the most part, right? Yummy. Okay. All right, so let's take a step back then. Let's if it is in this form, that is remarkably useful. So let me talk about that form, and then I'll remind you guys about the shortcut. So if I have a function that's not in that form, how do I put it in that form? So if I have something like, we'll do this example, and then I'll do that second example on that handout that I left for this time. What do you want, Jeff? I don't know, Jeff. I like it. Now, I went into the whole thing about Indiana Jones, and I gave you sort of a suggested homework assignment to go watch the damn movie. It doesn't have a due date, just do it. First, I got to make some room like I always do, but this time I make room like that. Because I really can't do anything with f of x. It's not really a side I can work with, so I just got to do everything on one side. How do I figure out what goes here? Yeah, negative 10 divided by 2. Negative 5. Negative 5 squared is 25. So that 25 goes here, and what happens over here? I like it. You guys see how that's almost like stupid? So did I really just change anything? Nope. So I didn't do anything illegal because I didn't do anything. Right? No ossifer. I subtracted and added. I did nothing illegal. I'm going to move along now. So then but the thing is, I've reorganized things. I've actually kind of unorganized them. Well, these first three, how do they factor?
X -5.
Yeah, x minus 5 squared. And then what do I get on the outside here? All right, so now that I got it in that form, I could see everything. Right? To be honest, I could see the most important parts of the parabola from this form, but let me see if you guys see this. So the vertex obviously is going to be what now? 5, negative 20. Does it open up or down? Up. And I actually knew that from the beginning also, right? What about the y-intercept?
0, 5.
Yeah, please, dear God, don't use this shit for that. Look at this. This is beautiful for a y-intercept. What do you do to get the y-intercept? Make x 0. All right, so the y-intercept is 0, 5. That form is beautiful for a y-intercept. Now, if you put a 0 in here, you will eventually get 5. Right, negative 5 squared is 25, minus 20 is 5. But I might as well just look at the form that's got the answer staring me in the face. Maybe. Just like mx plus b, the b is the y-intercept because the mx shit goes away. Well, all this shit goes away, that's the y-intercept. Same way. Alright, how you guys feeling about just the idea of how to get that to look like this? That's one skill. And then how to interpret this is down here. That's another set of skills. Quite been decent. What's that? Up here? Just to move that 5 over a little bit.
I understand that.
And then you do the steps that completing the square needs all the time. Cut the middle dude in half. Square. So that 25, I added 25 here. So at the same time, I better subtract 25 so that no boulders come and kill me, right? So we added 25 and subtracted 24. So. Say again? Totally. Why? Because what form do I want things in? I want them in this form. So, I desperately want you to understand, did I factor the function? Did I factor this function anywhere? Nope. I didn't factor that function any damn where, and that's not what this problem wants me to do. It wants me to put it in the form of something factored plus or minus some other piece. This is not factored. This is something minus something. I ain't factored. We're factored 10. 8 plus 2. What the hell's wrong with it? Right? This isn't factored, but I factored a piece of it so that it went into this form. Because if it's in this form, I know the vertex, which is arguably the most important point. Now, with all that said, I can then make you graph and all kind of business. With all that said, what was the shortcut we actually realized exists? Let's look at this thing again. The shortcut to the vertex. And actually, remember, what is this? We talked about where the vertex would be in relation to the intercepts. And where does the vertex have to be in relation to the intercepts? It has to be right in the middle, because of symmetry. Yes?
This is the vertex equation?
It's the shortcut way to get the vertex. Yeah. If the book calls it that, then great for the book. I don't care about names. Shortcut to get the vertex. Okay? Yes? You okay? Okay. Yes, totally. I'm trying to remind everybody why it's true. If the vertex is always the thing in the middle of the intercepts, and what is it that always gets me the intercepts of a quadratic? What always gets me, whose job is it to get me the x-intercepts of a quadratic equation? So what's a quadratic equation look like? Somebody help me out. Ax squared, bx, c. If I want to find this guy's x-intercepts, I set it equal to 0. So what solves this? Quadratic formula. And we talked about this yesterday, how if you look at this, this is negative b over 2a, give or take this. So what's always in the middle? So again, there's two things. Everybody cool with the fact that whatever the intercepts are, the vertex has to be right in the middle of them. Does that make sense by itself? Because of symmetry. It's perfectly symmetric. So if I hit the x-axis here and there, I can estimate that the vertex is right there. Right in the middle of the two x-intercepts. It's got to be, because it's symmetric. And what are the intercepts for any quadratic equation kind of looking thing? This. And what's in the middle of those? This is, by definition, right? Negative b over 2a plus this minus this. What's in the middle? Freaking negative b over 2a. That's the guy you added something to and subtracted something from. So of course he's in the middle. So yes, the formula, that's the shortcut to the vertex. Negative b over 2a. That gives you the x piece of the vertex. So in this case, what's b? Yeah, so negative b over 2a, what's a? 1. So I get 10 over 2 is 5. So x is 5. How do I find the y piece of the vertex? What do I do anytime I know x and I want to know y? Plug it in. So what's f of 5? It'd be 5 squared minus 10 times 5 plus 5. Just plugging it in. Is that cool? If I know the x piece of a point, how do I find the y piece of the point? Plug the x in. That's what the function does. If I plug x in, I'm going to get what y is. So what do I get here? F of 5 is 25 minus 50. Negative 25. Plus 5 is
30.
So the vertex here is 5, negative 20. What did we get for the vertex a minute ago? 5, negative 20. All right. So it's just a shortcut method to get the vertex. You don't have to put it into standard form unless they tell you to. If they just say find the vertex, screw standard form. Let me just do negative b over 2a. Yes. Does that mean you don't have to know how to put it into the right form? No, you got to know that too. He's going to ask you to do that too. Yes?
So the negative b over 2a is just to find the vertex, not...
Just to find the x piece, yeah.
Just, yeah.
Plug that in, get it in. So it's only a shortcut to get to the vertex. Exactly. I like it. All right. So let me see if I can unleash you guys on something here. Let me steal some more paper from some student who left their book here. That's what you get for doing that. All right. Evil math people, steal your shit. Oh, that's right. Before I get too far away, I want to do that other problem real quick. Before I get too far away. Where'd you go, other problem? Here you are. This guy. So let me start over a little fresh here. I gave you a little hint as to what we had to do with this. So remember, to get it into this form, I have to use completing the square. And completing the square requires what coefficient out front? A 1. So the very first thing I have to do here, I can't divide everything by negative 3 because I can't really divide f by negative 3. So again, I've got to do everything on this side. I'm going to move the minus 8 over. What do I have left in? So I'm really just taking a negative 3 out of that piece. So I got x squared minus 4x. And now I got some room right there, sort of. Let me write that again, just to give myself a little more. So I took a negative 3 out, x squared minus 4x. Leave some room to work with. Now I can complete the square in here. Is that cool? Now real quick, let me ask you, let me see if you guys get this. In this function, is there a negative 4 anywhere? No. So what's that guy? Is there? You just told me there's no negative 4 in here at all. So is that really a negative 4? No, it's actually a 12, isn't it? Because there's a piece of it and there's a piece of it. So whatever's in here is not what it looks like. It's negative 3 times that dude. You guys get that? So we're about to do something very strange, unless you understand what I just said. There is no negative 4 in this whole damn thing. So what does that do in there? Because it's actually 12. It's just been broken up into parts. So whatever I put here is not what I actually did. Negative 3 times that thing is what I actually did. So let's complete this guy's square. What's the steps for completing this guy's square? Yeah, negative 4 divided by 2 is negative 2. Negative 2 squared, 4. So I'm going to put a plus 4 right here. I'm not going to put a minus 4 here, because I didn't just add 4. I didn't. What did I just do? Negative 12. So how do I undo negative 12? Plus 12. Oh, you guys are going to love that shit. You guys. So let me show you. Let me break it down a little bit. Right here, when I do this, what did I really just do? If I bring the negative 3 back in, that's a minus 12. Isn't it? That is a minus 12. So over here I have minus 8. I better add 12 to undo that minus 12 I just did. It's just the stupid completed square requires a 1, so I got to kind of take this part away, but I better put it back together when I figure out what to undo. Hopeful. Okay, and now let's see. How does this guy here factor? A negative 3 is just sitting out front. How does this guy factor?
X.
Yeah, x minus 2 squared. And what do I have out here? Plus 4. I like it. So what's that vertex? 2, 4. I love it. Does it open up or down? Down, because it's a negative. What's the axis of symmetry? Not the y-intercept, the axis of symmetry. I want you to realize something. It is, for an up and down parabola, it is always x equals the x piece of the vertex. Always. If it was sideways parabola, it would be y equals the y piece, but let's not worry about that yet. We're not doing sideways parabola yet. Alright, maybe. Possibly, maybe. Maybe not at all. Shit. Okay. There's still more people. I did, yeah. Alright, now here, you guys do what you can with this guy. Let's see, what I wanted to give you here. Do all that stuff. True. Kind of hoping that as you do more of these, some of these you just kind of know the number that works. I mean, what am I going to add to this? 4. Half of this negative 2 squared is 4. So what did I actually just do? I added 8. I added 8. Make sure that's what I just did. How do I undo that? Subtract it. So overall, I did nothing to that side, which is completely legal. In every state. So, how does this guy factor? Yeah, x minus 2 squared, and outside here I get? So what is the vertex then?
2 and 5.
Good. 2, negative 5. What's the axis of symmetry? X equals 2. Bam. X equals the x piece. That forces it to go through the vertex. A little mirror. Or actually, it's a really big mirror because it's infinitely big. What about the y-intercept? Yeah, just look here. Make x 0, I'm left with a 3. 0, 3. What about, how are you guys trying to do the x-intercepts? You could either use this form and set it equal to 0, or you could use this form and use quadratic formula, yeah. It doesn't matter. I didn't say to do it anyway. So if I use, let's remember quadratic form. If I use quadratic formula, this will be x equals negative b, so it'll be 8, give or take, negative 8 squared, 64, minus 4 times 2 times 3, right? All over twice 2, twice 8. So x equals 8, give or take, 64 minus 24, 40. All over 4, x equals 8 plus or minus 4 times 10, square root of 4 is 2. And I can divide everything by 2. So I'll make this 4 plus or minus rad 10 over 2. So I can stop here. And then if I needed to, if I asked you to, I'll say make decimal approximation, which just means plug 4 plus rad 10 over 2 in your calculator, 4 minus rad 10 over 2, get the little decimals. Is that cool? Just remember, yes?
So you write it is that column 0 for the x?
Yeah, I mean, so for example, in my math lab, they're making you tear those apart and putting them. So yeah, it'd be 4 plus rad 10 over 2, comma 0. 4 minus rad 10 over 2, comma 0. But I'm saying, even go one step further, make them decimals. Because in decimals, you can kind of see where they go on the x-axis. Where is 4 plus rad 10 over 2 on the x-axis? I don't know. Shit. Let's make it into a decimal so I can approximate. Yes, ma'am?
Whenever you want to find the x-intercepts, do you always have to use the quadratic form?
Nope. So right here, I feel like I told Lindsay to ask me that question, but I did not. You could take this and do what? To find the x-intercepts. I can set this equal to 0. Add 5, divide by 2, square root. Add 2, so I get 2 plus or minus rad 5 over 2. Now, are these the same? Yes, they are. What can I do here? Could I say 4 divided by 2 is 2? Rad 10 over 2. Now you can still say, look, they're not the same, Jeff. I'm not saying you sound like that, but some of you do. How do I rationalize? I love you guys. You're all like, what the shit? This is too much. We know all these little things I'm doing. How do I rationalize this? Isn't that rationalized? Is that rationalized? So don't be telling me they're not the same, because you can't compare them. They're not in the same form. You can't compare them. How do I rationalize this? Multiply top and bottom by what? And you're all like, that was the last test, yeah. Yeah, and he's another rad 2 on the bottom. So isn't that 2 plus or minus rad 10 over the same, oh my gosh. Of course they're the same. Of course they're the same. You plug them in the calculator, you get the same decimals. They just don't look the same because they're not the same form, but they are the same number. It's like saying that 7 is not 14 over 2. They don't look the same. Like, wait a minute, dude. That's an issue. Okay. Let me see. All right. What else can I throw in before? I want to tell you that the section we're going to talk about tomorrow, and whenever I say the word tomorrow, you guys start backing up. Just hang on. The section we're going to talk about tomorrow is going to involve the thing you've been like, when is this coming? I want this to happen. The word problems have to be in here somewhere. And you can tell I'm not going to skip that. I'm not going to stop that. I'm going to let it happen. I'm going to let it fall on your head. But so we will do a little review of word problems, and then we'll look at the ones that create quadratic equation kind of word problems. Okay. So let's see. There was one last thing I wanted to say. Oh, real quick. This guy here. Do the shortcut real quick for the vertex and verify that the vertex is the same both ways. So let me write it up here again. Do the shortcut for the vertex. Find the vertex again. You couldn't do that on the one I gave you because I didn't tell you you could do it. I told you you had to do it the other way. So you get negative 8 over twice 2. So you get 8 over 4 is 2. And then when I plug a 2 in, this is how I get the y piece. When I plug a 2 in, I get 2 times 2 squared, 2 times 4 minus 8 times 2 plus 3. I get 8 minus 16 is negative 8 plus 3 is negative 5. So I do get 2, negative 5 as my vertex. Of course, it's the same work, it's a shortcut. It's just doing the same work, to be honest. And that's plenty, I believe. Tomorrow, we'll get into the quadratic word problems. That just sounds awesome to say. I'm going to give you guys the practice test tomorrow. And Monday will be review day. Today and tomorrow, quiz. Level 1, level 2, and level 3. It's going to happen right now for some of you guys. You're smart. Come to the lab.